Lockheed Martin, one of the largest defense contractors on the entire planet, just quietly sent a wave of its own engineers back to school. And the subject wasn't cybersecurity, it wasn't AI, it was quantum computing. Not a research division, not a handful of PhDs locked in a basement lab somewhere. Actual working engineers, the people who build fighter jets, satellites, and missile systems, are now sitting through structured coursework on qubits, superposition, and quantum algorithms. If a company this size, this cautious, and this deeply embedded in national security decided this was suddenly urgent enough to retrain its own workforce, that tells you something the headlines are not shouting loud enough about yet. Here's the actual story, because it just broke, and most people scrolled straight past it without realizing what it means. In July 2026, Lockheed Martin expanded a program called the Quantum Talent Pipeline, teaming up with a quantum computing company called Xanadu to train engineers from across a completely different technical backgrounds, from mechanical engineering to computer science and practical quantum computing skills. This wasn't a one-off workshop or a single afternoon seminar. It was a structured, ongoing training pipeline using real coding tools, real tutorials, and real hands-on exercises built specifically so these engineers could apply quantum methods directly inside their day-to-day research and development work. Let's slow down and ask the obvious question, because it's the one nobody in the press release actually answers directly. Why now? Why would one of the most conservative, risk-averse companies in the entire aerospace and defense sector suddenly decide that quantum computing training is not optional anymore? It's a bottleneck that needs solving immediately. Companies like Lockheed Martin do not chase hype. They do not retrain engineering staff because a technology sounds cool on a conference stage somewhere. If they're investing serious internal resources into this right now, in the middle of 2026, it's because something in the underlying technology landscape has shifted enough to make waiting any longer feel genuinely risky. To understand why, you have to understand what quantum computing actually threatens to unlock inside defense and aerospace specifically. Because it's not just about faster computers doing the same old jobs quicker. Quantum computing threatens to fundamentally change materials, science, logistics, optimization, radar and sensing technology, and, most alarmingly, the encryption protecting nearly every classified system currently in operation. When a technology touches that many pillars of national security simultaneously, waiting on the sidelines stops being a cautious strategy and starts becoming a genuine liability. And if that thought just made the hair on your arm stand up a little, that's honestly the appropriate reaction. So go ahead and hit that subscribe button now, because we're only just getting started. Let's talk about the Xanadu partnership specifically, because the company Lockheed Martin chose to work with matters just as much as the decision to train engineers at all. Xanadu is a photonic quantum computing company, meaning their approach to quantum hardware uses light, actual photons, to carry and process quantum information instead of the more familiar superconducting circuits used by companies like Google or IBM. Lockheed Martin and Xanadu had already been collaborating on quantum machine learning research before this training expansion was announced, which tells you this wasn't some rushed, reactionary decision made overnight. This was the natural next step in a relationship that had already been quietly building underneath the surface for a while. According to Xanadu's own leadership, the goal of this partnership is to help engineers who already have deep domain expertise bridge the gap into the unique advantages quantum technology actually offers. That phrase matters more than it might sound at first. Lockheed Martin isn't hiring an entirely new army of quantum physicists from scratch. They are taking engineers who already understand aerospace systems, already understand materials, already understand the mission-critical problems the company deals with every single day, and teaching those same people how to apply quantum tools directly to problems they already know, intimately. That is a fundamentally different and, frankly, much smarter strategy than starting from zero. And here's a detail that should genuinely catch your attention if you care at all about where the biggest technology jobs of the next decade are heading. The training program specifically pulls engineers from wildly different technical backgrounds, mechanical engineering, computer science, and beyond, and funnels them into the same quantum coursework. That means quantum computing skills are no longer being treated as a niche specialty reserved only for physicists with a doctorate. Lockheed Martin is explicitly signaling that quantum literacy is about to become a baseline expectation across multiple engineering disciplines, not an exotic bonus skill on a resume. If you're anywhere near the engineering world and this doesn't at least make you pause for a second, it probably should. Now, let's zoom out, because Lockheed Martin is not moving in isolation here. And understanding the broader picture is exactly why this particular headline landed with so much weight. The United States government has been pouring enormous resources into quantum computing throughout 2026, treating it as a matter of straight-up national competitiveness. In June 2026, the White House issued executive action explicitly framing quantum information science and technology as central to maintaining American leadership, warning that other nations are moving quickly to challenge that position. This built directly on an earlier 2026 announcement of $2 billion in incentives aimed at strengthening domestic quantum manufacturing and supply chains, including direct equity stakes in quantum computing companies. When the federal government starts taking equity positions in an emerging technology sector, that is about as clear a signal of strategic urgency as it gets. And the reason for that urgency comes down to one specific, deeply uncomfortable mathematical fact that has been sitting quietly in the background of every serious national security conversation about quantum computing for years now. A sufficiently powerful quantum computer, using an algorithm mathematicians have understood for decades, could theoretically break the encryption protecting almost every piece of sensitive digital communication currently in existence. That includes classified military communications, satellite command systems, and the kind of encrypted data that intelligence agencies consider absolutely critical to protect. This is not speculative fiction. This is a well-documented mathematical vulnerability that the entire cybersecurity world has been racing to patch before quantum hardware becomes powerful enough to actually exploit it in the real world. That race even has a name inside intelligence and defense circles, and once you hear it, you won't forget it. It's called Harvest Now, Decrypt Later, and the concept behind it is genuinely unsettling if you sit with it for more than a few seconds. Adversarial nations and hacking groups are already collecting massive amounts of encrypted data right now, today, while current encryption still holds strong, specifically betting that quantum computers powerful enough to crack that encryption will eventually exist. When that day comes, all of that harvested data, communications, financial records, classified files, becomes instantly readable, even though it was collected years earlier under the assumption that encryption made it safe forever. If that idea doesn't unsettle you a little, you probably weren't paying close enough attention, and if it did, smashing that like button right now genuinely helps more people see this before it becomes an even bigger story. This is exactly why one recent US government report described the shift toward quantum readiness as the most pressing technological challenge since the Manhattan Project, a comparison that is not thrown around casually inside serious policy circles. The Department of Defense has been explicitly warned that without a serious overhaul of cybersecurity, infrastructure, intelligence architecture, and strategic planning, the country risks catastrophic vulnerabilities. By the time quantum computers mature enough to pose a real threat, something many experts place somewhere around the year 2030. That is not decades away anymore. In planning terms for a company like Lockheed Martin, that timeline is uncomfortably close. And it is precisely the kind of pressure that forces a massive, historically cautious organization to suddenly start retraining its own engineering workforce years ahead of when the public assumes any of this actually matters. Let's talk about what this means specifically for Lockheed Martin's day-to-day business, because national security headlines are dramatic, but the practical ground-level applications are honestly just as important to understand. Aerospace and defense engineering constantly deals with problems that are, at their core, absurdly complex optimization challenges. Designing a new alloy that is both lighter and stronger than anything currently available, optimizing global supply chains for parts that need to arrive at exactly the right facility at exactly the right time, modeling how radar signals interact with new stealth coatings under conditions that are almost impossible to fully simulate using classical computing methods alone. These are exactly the kinds of problems quantum computing is specifically well suited to eventually tackle, and they sit right at the center of what Lockheed Martin actually does every single day. Quantum machine learning specifically, the exact area Lockheed Martin and Xanadu had already been researching together before this training expansion, focuses on using quantum-enhanced techniques to spot patterns and optimize systems in ways that classical machine learning genuinely struggles with at certain scales. In an industry where a single percentage point of efficiency in fuel consumption, radar detection avoidance, or materials durability can represent enormous strategic and financial value, even modest quantum advantages translate into real competitive differences on the battlefield and in the marketplace simultaneously. That is precisely why a company like Lockheed Martin would rather spend the next several years training its own people now, quietly, internally, instead of scrambling to catch up once competitors or adversaries get there first. And make no mistake, this is very much a competitive race, not a solo research project happening in isolation. Reports throughout 2026 have repeatedly framed quantum development as a direct extension of ongoing technological competition between global superpowers, particularly the United States and China, both of which are actively developing quantum technologies with serious military applications, from next-generation radar and navigation systems to entirely new categories of secure communication. NATO itself announced its own dedicated quantum strategy, explicitly promoting what officials described as a transatlantic quantum community among allied nations. When military alliances start building formal quantum strategies at that level, and individual defense contractors start retraining entire engineering cohorts internally, that is a very clear signal this has moved well past theoretical research and firmly into active strategic planning. Here's something that deserves genuine attention, because it's easy to miss inside all the geopolitical framing. This entire shift represents a massive change in what defense engineering careers are going to look like over the next decade. And if you're someone building a technical career right now, this is worth paying very close attention to. For years, quantum computing careers were assumed to require a physics doctorate and a research position inside a university or a specialized lab. Lockheed Martin's approach flips that assumption completely on its head. They are explicitly training mechanical engineers and computer scientists, people already working inside mainstream engineering roles, to layer quantum skills directly on top of the expertise they already have. That is a dramatically more accessible path into this field than most people currently realize exists, and it's happening right now, quietly, inside one of the largest defense contractors on the planet. If you've made it this far, you're clearly the kind of person who wants to understand where major industries are actually heading before it becomes mainstream news everywhere else. So go ahead and subscribe now, because this channel is going to keep tracking exactly these kinds of quiet, high-impact shifts as they happen in real time. Let's talk about the broader defense industry context here too, because Lockheed Martin is a massive company, but it is far from the only major player suddenly racing to build internal quantum expertise. Throughout 2026, quantum computing companies with direct defense applications, including firms working on trapped ion and neutral atom quantum hardware, have been attracting serious investor attention, specifically because of new government policy shifts and executive actions explicitly tied to national security priorities. Defense stocks and quantum computing stocks have started to blend together in a way that would have sounded strange even just 2 or 3 years ago, and that blending itself tells you the industry now views quantum capability as inseparable from long-term defense competitiveness. There's also a workforce pipeline problem underneath all of this that Lockheed Martin's program is quietly trying to solve before it becomes a full-blown crisis. Quantum computing talent is genuinely scarce right now, globally, across every single industry trying to build quantum capability simultaneously. Universities are producing quantum-trained graduates at nowhere near the pace major corporations and government agencies actually need them. Rather than compete in an increasingly expensive and increasingly limited hiring market for scarce quantum specialists, Lockheed Martin made the strategic decision to grow that talent internally instead, using existing engineers who already understand the company's mission-critical systems intimately. That is a genuinely smart long-term strategy, and it's one other major companies across completely unrelated industries are very likely about to start copying as this talent shortage tightens even further. Let's also be honest about the limitations here, because a complete picture always requires acknowledging what current quantum hardware still cannot do. No matter how urgent the training pipeline feels right now, quantum computers today are still nowhere near powerful enough to break modern encryption standards or run full-scale simulations of complex aerospace materials from start to finish. The engineers going through this training right now are preparing for a capability that is still very much maturing, not one that is fully operational today. But here's exactly why that timing longer than the hardware itself takes to mature. If Lockheed Martin waited until quantum computers were fully capable before starting to train its workforce, the company would already be years behind by the time that hardware finally arrived. This pattern is not new, and it's worth remembering that defense contractors have used exactly this playbook before with other emerging technologies throughout history. Companies like Lockheed Martin invested heavily in early artificial intelligence and machine learning talent years before those technologies became fully mission-critical inside actual weapon systems and logistics platforms. The lesson from that earlier technological shift was simple, and it clearly stuck. Companies that waited too long to build internal expertise found themselves scrambling to catch up later, often paying dramatically more to acquire talent externally instead of growing it internally at a much lower cost over time. Quantum computing appears to be following that exact same well-worn playbook right now, just with even higher national security stakes attached this time around. Now here's a detail worth sitting with for a moment, because it connects directly back to that encryption vulnerability we talked about earlier, and it's exactly the kind of connection that rarely gets spelled out clearly in mainstream coverage. The National Security Agency has publicly stated it expects the full transition to quantum-resistant encryption algorithms across national security systems to be complete by 2035. That deadline was set specifically because migrating an entire nation's worth of classified communication infrastructure to new encryption standards is an enormous, slow-moving undertaking that cannot happen overnight, no matter how urgent the underlying threat becomes. Every single year Lockheed Martin spends now building internal quantum expertise ahead of schedule is a year that Timeline benefits from directly, since defense contractors are exactly the organizations responsible for building and maintaining huge portions of that classified infrastructure in the first place. And if you're wondering whether this quantum urgency is just a defense industry phenomenon confined to a handful of massive contractors, understand that it absolutely is not. Financial institutions, pharmaceutical companies, and major cloud computing providers are all independently racing to build quantum expertise for reasons specific to their own industries, whether that's portfolio optimization, drug discovery, efficiency. What makes the Lockheed Martin story specifically newsworthy is the combination of factors converging all at once: a historically conservative company, a national security dimension attached directly to the outcome, and a training program explicitly designed to pull talent from mainstream engineering roles, rather than waiting for a small, specialized pool of physics PhDs to magically become available at scale. Let's talk about what comes next, because this story is very clearly not finished unfolding. According to statements from Lockheed Martin's own quantum technologies leadership, the Quantum Talent Pipeline program is expected to expand to additional engineering cohorts moving forward, with plans for more educational materials, more hands-on workshops, and increased access to quantum computing tools across the company. That means this isn't a small pilot program quietly running in the background. This is a scaling operation, deliberately designed to grow larger over time, specifically because leadership inside the company believes quantum literacy is going to matter across a much wider swath of their engineering workforce than just a handful of specialized research teams. If you zoom out far enough, this entire story becomes a genuinely useful signal for any ONE trying to predict where major technology shifts are actually heading before they hit mainstream headlines everywhere else. Defense contractors do not typically move first on emerging technology trends out of pure curiosity or excitement. They move first when the underlying strategic risk of waiting has become larger than the cost and effort of adapting early. Lockheed Martin, quietly retraining its own engineers in quantum computing right now in the middle of 2026, is exactly that kind of signal, and it's the type of quiet, unglamorous news story that historians often look back on years later as the actual starting point of a much bigger shift most people missed completely the first time around. Let's dig into the specific tool Lockheed Martin's engineers are actually using, because the choice of platform tells you a lot about how serious and practical this training really is. Penny Lane, the quantum programming stack developed by Xanadu, is not some abstract theoretical framework built purely for academic research. It is a real, functioning software toolkit designed specifically to let engineers write quantum machine learning algorithms using programming patterns that already feel familiar to anyone with a classical software background. That detail matters enormously because it means Lockheed Martin's engineers are not being asked to abandon everything they already know and start from a blank slate. They are being handed tools deliberately designed to feel like a natural extension of skills they already possess, which dramatically shortens the runway needed to get a working engineer from curious beginner to genuinely productive with quantum methods. This approach also explains why the training pulls from such a wide range of technical backgrounds instead of narrowly targeting physicists. Mechanical engineers understand structural stress, materials behavior, and complex physical systems intimately, even if they've never touched a line of quantum code in their life. Computer scientists understand algorithms, data structures, and computational complexity, even without a background in quantum mechanics specifically. Penny Lane and similar quantum programming tools are essentially designed to bridge exactly that gap, letting domain experts stay domain experts while adding a new computational tool to their existing toolkit, rather than forcing them to become physicists first and engineers second. Now, let's talk about quantum sensing for a moment, because it's a piece of this puzzle that rarely gets the attention it deserves, even though it may end up mattering just as much to defense applications as full-scale quantum computing itself. Quantum sensors exploit the same delicate quantum properties used in quantum computing, but instead of performing calculations, they measure the physical world with a level of precision classical sensors simply cannot match. This has enormous implications for things like navigation systems that don't rely on GPS, since quantum sensors can theoretically detect tiny changes in gravitational or magnetic fields precisely enough to calculate position without ever needing a satellite signal at all. For a defense contractor building aircraft, submarines, and missile systems that sometimes need to operate in GPS-denied environments, that capability is not a nice-to-have feature. It is a potentially mission-critical breakthrough. Radar is another area where quantum technology quietly threatens to upend decades of established defense engineering. Traditional radar systems work by bouncing radio waves off objects and measuring the reflection. But quantum radar concepts explore using entangled photons to detect objects with a level of sensitivity and resistance to jamming that classical radar systems cannot achieve. Nations investing heavily in quantum research are exploring exactly this kind of application, and if quantum-enhanced radar or sensing technology matures faster in one country than another, that creates a meaningful strategic imbalance almost overnight, the kind of imbalance that defense planners lose sleep over. This is precisely the sort of dual-use technology, useful for both civilian and military purposes, that policy experts have specifically flagged as reshaping global security dynamics throughout 2026. Let's also talk honestly about the competitive dynamic with China specifically, because it keeps surfacing throughout this story for good reason. Chinese state-backed research institutions have been investing enormous sums into quantum computing and quantum communication research for years now, with some of the most heavily funded quantum research programs anywhere on the planet. American policymakers have repeatedly framed the current moment as a race where losing quantum leadership to a strategic rival would carry consequences far beyond just falling behind on a cool new gadget. It would mean falling behind on the exact technologies underpinning next-generation encryption, next-generation sensing, and next-generation secure communication, all at the same time. That is precisely the kind of high-stakes competitive pressure that turns a slow-moving, historically cautious defense contractor into a company suddenly retraining engineers across multiple departments within the span of a single year. It's worth pausing here to talk about what this means for the broader engineering job market too, because this is genuinely one of the more exciting angles buried inside this entire story. For years, the conventional wisdom inside tech circles was that quantum computing careers required an extremely narrow, extremely competitive academic path, usually involving a doctorate in physics from one of a small handful of elite research universities. Lockheed Martin's training pipeline quietly demonstrates something very different in practice. It shows that meaningful quantum literacy can be built on top of an existing engineering career, without requiring anyone to go back and get an entirely new advanced degree first. If large employers across defense, finance, and pharmaceuticals start adopting the same internal training model at scale, the pathway into quantum-adjacent careers could widen dramatically over just the next few years. That shift alone deserves way more attention than it's currently getting in most career advice content online. There's also a fascinating historical parallel worth drawing out here, because defense contractors have quietly served as early adopters for multiple transformative technologies throughout modern history, often years before the broader public realized how significant those technologies would eventually become. During the early days of computer-aided design, defense engineering firms were among the first organizations to fully retrain drafting departments away from paper blueprints and toward digital modeling software, years before that shift became standard practice across mainstream manufacturing industries. During the early rise of machine learning and artificial intelligence, defense contractors again moved early, building internal AI expertise years before AI became an unavoidable buzzword across every single industry simultaneously. Quantum computing training at Lockheed Martin right now looks a whole lot like history quietly repeating itself, just with an entirely new technology wearing the hat this time around. And here's why paying attention to these early, unglamorous defense industry moves can genuinely pay off if you're trying to get ahead of a major technology shift instead of reacting to it after it's already mainstream news. Defense contractors have strong financial and strategic incentives to move. Early on, technologies they believe will eventually matter, but they also have strong incentives to move quietly without unnecessary hype, since overselling an unproven technology internally can waste enormous amounts of budget and engineering time. When a company like Lockheed Martin decides a technology is worth training hundreds or potentially thousands of engineers on, that decision passes through layers of extremely conservative internal risk assessment first. By the time that decision becomes public news, it usually means the internal case for the technology has already cleared a remarkably high bar of scrutiny. Let's also talk about the sheer scale of investment happening around quantum computing throughout 2026 more broadly, because Lockheed Martin's training program did not emerge in a vacuum. It emerged directly inside an environment of massive coordinated national investment. Beyond the $2 billion in federal incentives aimed at strengthening domestic quantum manufacturing, agencies across the government have been directed to share information about quantum computing supply chains more broadly, specifically to inform coordinated government-wide decision-making. The National Science Foundation, HAS, been tasked with issuing grants specifically to establish new quantum research infrastructure across the country. When that level of coordinated federal effort surrounds an emerging technology, defense contractors, sitting at the intersection of national security and advanced engineering, are almost always among the very first private companies to feel direct pressure to keep pace. There's a quieter human angle to this story too, one worth acknowledging honestly. Retraining an existing engineering workforce is not always an easy or comfortable process. even when the underlying strategic logic makes complete sense on paper. Engineers who have spent years, sometimes decades, building deep expertise in one specific discipline are now being asked to layer an entirely unfamiliar computational paradigm on top of everything they already know. Quantum mechanics famously defies a lot of the intuitive assumptions people build up over a lifetime of working with classical systems, and that learning curve is genuinely steep, even for extremely talented engineers. The fact that Lockheed Martin is investing in structured, supportive training pathways, rather than simply expecting engineers to figure this out alone, says something meaningful about how seriously the company is treating this transition internally. So where does all of this actually leave things right now in the middle of 2026 for anyone watching this story unfold from the outside? Quantum computing hardware is still maturing. Full-scale, fault-tolerant quantum computers capable of breaking modern encryption or running complete aerospace material simulations from start to finish do not exist yet. And most serious experts still place that milestone several years out at minimum. But the organizational groundwork being laid right now inside companies like Lockheed Martin is exactly the kind of preparation that historically separates the companies caught flat-footed by a major technology shift from the companies that emerge from that shift already several steps ahead of everyone else. It's also worth remembering that Lockheed Martin operates in an industry where mistakes are measured in lives, not just dollars, which makes their willingness to move on quantum training now even more telling. A company building fighter jets and missile defense systems cannot afford to gamble recklessly on unproven technology, yet it also cannot afford to be years behind when a genuinely transformative capability finally arrives. Threading that needle, moving early enough to build real expertise without overcommitting resources to a technology still years from full maturity, is exactly the kind of careful, deliberate calculation you would expect from an organization this deeply embedded in national security. That balance, more than anything else, is what makes this specific story worth paying such close attention to right now. So here's the real question worth sitting with after watching all of this. If one of the most cautious, risk-averse companies in the entire defense industry has decided quantum computing training can no longer wait, what does that tell you about how close this technology actually is to becoming genuinely operational inside the systems protecting national security every single day? What does it tell you about the encryption protecting your own data right now, sitting quietly in servers somewhere, waiting for a decryption capability that intelligence agencies are already actively planning around? And what does it tell you about the career opportunities quietly opening up for engineers willing to learn quantum skills right now, years before this becomes a mainstream expectation across the entire industry? Think about how this same pattern played out with cybersecurity investment 2 decades ago, because the parallel is honestly striking once you lay it out side by side. Back then, most companies treated dedicated cybersecurity teams as an optional expense, something nice to have but not urgent, enough to justify serious internal investment. Then, a wave of high-profile breaches made it brutally clear that waiting had been a mistake. And suddenly, every major company on the planet was scrambling to build cybersecurity capability from scratch, paying a massive premium for talent that could have been developed internally years earlier at a fraction of the cost. Lockheed Martin's quantum training pipeline looks like a company that has clearly studied that exact lesson closely and has decided, quietly and deliberately, not to repeat it a second time with an entirely new technology. The honest answer is that this story is still in its opening chapters, and the people inside Lockheed Martin and the broader defense industry clearly know it too. If you want to keep tracking exactly these kinds of quiet, high-stakes shifts before they become the headline everyone else is suddenly scrambling to understand, make sure you're subscribed, because this channel is going to keep digging into precisely this kind of story as it continues to unfold. Thanks for watching all the way through, and I'll see you in the next one.